we have a two-legged traverse with given information, and we need to calculate the coordinates of point C. So let's see what is given. We have station B, and at station B we have two courses that are meeting. The first course is BA and the second one is BC. The angle between these two at station B is 95 degrees 45 minutes and 35 seconds. The length of the line BC, it is 225, it's given, and the coordinates of station A and station B, they are given. The easting of point A and the easting of northing of point A, the easting of point B, and the northing of point B. So we are required to find the coordinates of point C. Let's see here. If you want to calculate the coordinates of point C, all what we have to do, calculate the departure between B and C, which is this one, delta E from B to C. And then we want to calculate the latitude, delta N from B to C. So if we calculate these departures and latitudes of the line or of the course BC, then all what we have to do, we'll take the coordinate of easting of coordinate B and add to it the departure between B and C. Then we will take the northing of point B, which is this one, and add to it the latitude between B and C. How do we calculate delta E and delta N between B and C? Look at this figure here. We have this equation. We learned this chapter 2 before. So delta EBC, it equals the length of the line, BC, and we have to multiply it by sine of the azimuth from B to C. So this is B and that is C. Now, what is the delta NBC, which is the latitude? Also, it's the same thing, but the length of the line, but multiplied by cosine the azimuth. Now, if you look at the problem, you will see that L is given as 255, as you can see here. L is 255.84, but we do not have the azimuth. So where are we going to find the azimuth of line BC? If we look at the figure here, I'm changing the colors and changing the layout for better understanding. So if we just emphasize, this is line BA, and it has an azimuth alpha BA, and we have the line BC, and it has an azimuth alpha BC. The alpha BC is the one that we need to calculate. But do we have the alpha BA? Supposedly we have it, or we do not have it. What is the relationship between alpha BA and alpha BC? Alpha BC it can be calculated from alpha BA, and because the relationship is counterclockwise angle between the course BA and BC, so we'll take alpha BA and then counterclockwise. That means we subtract, because the counterclockwise angle will reduce the azimuth. So it is alpha BA minus the angle between these two lines, which is given by 95 degrees 45 minutes and 35. Now we have to find alpha BA. If we find alpha BA, we can find alpha BC through the angle between these two courses. So look at the problem again. We can see that we are given A coordinates and the B coordinates. So once we have the end coordinates, we can find the azimuth of line alpha BA. How? We took it before and in chapter 2, and we have used this table before. The side BA, or the course BA, we have the first point as point B, and these are the coordinates. And we have point A, the second point. This is the first point, and this is the second point. And we have the coordinates of point B, which is the first point, and A as the second point. What is delta E? Delta E, it is the E of the second point minus the A of the first point. So it is the 738.23 minus 423.58, and this will give you 314.65. Let's see for the northing, delta northing. Actually, what we are calculating now, we are calculating these. So this is delta easting between B and A, and this is delta northing between B and A. Once we find them as delta E here in the table and delta N in the table, the length is not required to be calculated, but we calculated that anyways. Then we go to the tan. We have to evaluate first the tan inverse of delta E over delta N between B and A, and then we will find that it is 57, 58, 14.02. Of course, we always put the delta E and delta N by their signs. Whatever signs we have it, positive or negative, we'll put it in the calculator for the tan calculations. Now, as you knew in chapter 2 also, that we have to check the quadrant. If you are in quadrant 1, then there is an adjustment of 0. The best quadrant is the first. If you are in the second quadrant, you add 180. In the third, you again add 130. This table is now very well known to you. So because we have positive in the delta E and positive in the delta N here, which is the first case, that means we are, and the tan minus 1 inverse will give you a positive value, that means you are in quadrant 1. In the quadrant 1, we do not add any adjustments to the tan inverse result. So we add a 0, and then add a 0, and this will equal to 57 degrees, 58 minutes, and 14.02 seconds. What is this? This is the azimuth alpha BA. So now alpha BA is here. So let's move and find the azimuth of the connected line at B, which is BC. We want to find alpha BC. We go to the figure again here, and we said the alpha BA, we just found it to be 57, 58, 14.02. We have the angle between the two courses as 95. The direction of the angle is counterclockwise because we are moving from the known to the unknown through this angle, which is going counterclockwise. So alpha BC equals 57, which is the alpha BA, minus the 95. As you can see, the result is negative. Anytime we calculate an azimuth and we find that it is negative, all what we have to do is add 360 degrees because it cannot be negative. So adding 360 degrees plus the minus 37, it will give you 322, 1240.02 seconds. Now, what do we have? We have the azimuth of line BC. So this one is no more unknown, it is known. So what are we going to do with it? We have to calculate alpha, delta, which is the departure of the line between B and C. So we're going to calculate the departure and we calculate the latitude. The angles, the equations, these are the equations. Delta EBC equals the length of the line. It is given to us as 255.84 meters multiplied by sine the angle, sine the azimuth of the line BC, which is 322, 1240.02. This will give me a negative 156.767, and this will give us the latitude. It will give it a positive 202.974. What are we going to do with these? As we saw this before, we will take the given easting of point B and you add to it the departure, and this is a negative one. So we take this negative one and you add them together, it will be 266.823. What is this? This is the easting of point C. The northing of point C, the same thing, but we will take the northing of point B and then you add to it the latitude that we just calculated for the line BC. And that's it.